Hi, I'm GUO Primary 6 from YUMIN Primary School. For this time, we are still at ordinary differential equations. For this type of ordinary differential equations, let me just tell you, we're going to make comparisons in differential equations with homogeneous functions, but in which area of it? So let me tell you what area are we looking at. So these differential equations with homogeneous functions, we can use the homogeneous substitution. But homogeneous substitution, you can think of different types of it, but which is the best? So let me tell you how many types there are. First thing to consider, when you get this differential equation, first thing you'll think, do we need to take the original form, or do we need to take the reciprocal form? So this is one problem, original or reciprocal. So this already had two cases. Then after that, during the substitution process, you need to think, because you need to let something be u. So what is it? It can be y over x, it can be x over y. Well, another two cases. So that means we have 4 cases in total. And for these 4 cases, well, we'll tell you which case is the best and which is the simplest. So in the last lesson, we have already done one of these cases. That is, we don't take the reciprocal and we use y over x. That is equal to u. So now we're going to use another method. Then at last, I'll show you a comparison of these methods. Okay, so right now we're using the second method. For the second method, would we take the reciprocal or not? Well, we can take the reciprocal. So let me just write this down first. Okay, if we take this reciprocal form, later during this substitution, how would you want it to be? Y over x or x over y? Well, first, can we simplify this a little bit? Even though we write it like this, you can let y over x, you can also let x over y be equals to u, like this. Then that means you have to change this. So at first, in the first method, it is y over x is equals to u. Well, in that case, you change the y for u and x. And basically that becomes u is a function of x. And in this case, now it's x over y that's equals to u. That means you change this x for u and y, and u now becomes a function of y. So here, this part, using a product rule. Then for this part, so you can move this u to the other side. Then after that, when you move this to the other side, you still have to common denominator. And this common denominator is a u square. So by this order, it becomes like this. After that, what do you need? U, this is on one side, but this du is here. But why this times and this divide? So we might want to put u on one side, y on the other side. So that means you have to divide this whole thing. That is why I need to use this common denominator. Well, at the same time, this numerator becomes a denominator and you can factorize. So for this factorization, well, you can have this thing, okay, then this divides to the other side. Indefinite integration. Okay, so for this part, we'll need to use partial fractions. So for this part, partial fractions are right out there. In this part of partial fractions, from here, we can let these numerators be a, b, and whatever. So for this first part, 1 minus u, a. Since this part is just that square, so okay, you can put it like this. Then right now, we can compare the coefficients of these, whether it's u squared, u, or the constant. So if it is u squared, what would you have? If this is from u squared, well, we might want to write the whole thing out so that we can see clearly which part is for what. And this whole thing is just equals to u squared. So right now we can find out which parts have this u squared. Firstly, a. Then from this part is minus b. Coefficient is 1. Then how about u? You have b minus c. And you get 0. Since there is no u over here, so that means the coefficient is just a 0. Since 0 times anything is just 0 in this part. Then this constant, you have this a, then you have this c. And this constant is still a 0. So from this part, it just becomes like solving linear equations. So this part is just like solving linear equations. From these two, you can first cancel b. And it becomes like this. So then you can go on to find out what are these. Okay, so now I found out these. Now I can start these back. But then you'll realize each of these have a half. So this half, it can be factorized. And for b and c, both of these, they have a minus. So that means you can just put it as minus this whole thing. Okay, then that means for this part, Okay, you get this part. So for this part, let me just split it into two different parts, and you can solve them like individually. But this part, simple. It is, you have this log. But this part is a little bit more like complicated. So at this part, we can use partial fractions and split these into two more fractions. So this part, partial fractions, okay. But for this part, if you want to put this u inside, well, you can, and you'll get a u square. But here in front is 1. So when you go inside, it becomes half u squared. So you need an extra 2 there. So that means this part comes along. And then at this part is the inverse tangent. Then over here is just this constant. So at this part, now we can both sides integrate at once. So is this log 1 minus u. Then after that is what we have calculated over here. Then for this other part, it's just a log. So here's your first arbitrary constant c. After that, you can both sides times 4 to remove all these fractions. Then at the same time, you can also put these two longs over here. So this moves to the other side, plus times 4, here's a 2. Then for these three parts, you can put them together into one log. Well, these coefficients will become the power. Wait, here this constant changes. Then both sides, you can subtract this u. But this u, from what we have written there, is x over y. So x over y, you can put this y inside. Like this. After that, what happens here? So right now, you can on both sides use the exponential. Then this constant just remains as a constant. then actually you can just write this as your answer. Well, how does it match with this? Wait, one part I missed out. These are 2. Since you times 4 on both sides. Okay, so how does this match up? This part, well, although there will be negative, but beware, here's a square. So negative and negative is still just positive. So this first part, same. Second part, very obviously, both are positive. So you're staying. Then for this last part, you have this extra negative. But inside the tangent, it is a reciprocal. So if you flip this part inside the inverse tangent, then you get extra negative. So basically, it's still the same. So that means this answer is correct. Okay, so this is the first method. This is the second method that we have here. Well, these 2 methods. How about the methods I said? The other 2 methods. Well, I'll just write their starting, and then I can actually tell you from their starting how hard would it be afterwards. Okay, so for this, can I erase this part? Okay. I think this part, we also don't need it. Okay, so let's check what we have here right now. We have already done this non-reciprocal and use y over x. How about non-reciprocal but x over y? So this is the third, because this is second. So third is we use this part like this. So we let x over y be u, and that means x would be u times y. Now what happens here? X is u times y. Then when we start this inside, but wait a second, here is y. So you need x over u. Like this, then it's more like it. Put this inside quotient rule. No, quotient rule, that will make it complicated. So we use a product rule. Product rule first with x, then after that u. Then at this part, x squared over x. Okay, like this. Then from this part, we can simplify that x squared. After that, what happens? This part, common denominator in this denominator. Then after that, the denominator of the denominator will become the numerator. Then from this part, we move it here. But this part is getting a little bit more hard. then you get 2 of these u squared. Like this. But then what happens here? Wait. I put it wrongly, sorry. Wait, so this part times u. This part times u squared minus u plus 1. I think like this. Okay, then from this part you already get something like that. And then this u squared, you have to times it to the other side. So one of these u's will simplify. Like this, but actually this numerator, you could already factorize it. So let me just show you what it looks like when you factorize it. Then to change these two places, it's just from this negative here. Okay, but from this part, when you compare with this part, or you can also say it's this part, since this part you also factorize it, well, you have this extra u. You have this extra u here. So that means afterwards, at this part, you have 3 fractions. Then that will of course make it more complicated. Okay, so this is the third method. How about this fourth method? So this is definitely more complicated. How about the fourth method? Method 4 is from this part, so this is the reciprocal form, and at first we use x over y. Now we use y over x. Okay, now you get something like this. Then for that first part, you can use the product rule. Okay, then for this second part, it becomes like this. How about we change this 1 over u to the other side? Then it becomes like this. Now what happens here? You still have the common denominator. Like this. You get something like this. Then after that, you change this u squared to the other side. Then from this part, you also can factorize. Okay, like this. Wait a second. Okay, now you get it like this. Just to change these two places, here's that negative, so you can use it to change. But what happens here? When you put this to the other side, that means you divide this whole thing to the other side, it becomes 3 terms at the denominator again. Then that means when you use the partial fractions, there'll be 3 fractions. And although this numerator, it looks simple, but when you work it out, it'll have more terms. And that will make it more complicated. Okay, but no matter which method you use, they'll actually all give you the same answer. It's just about its complexity. Okay, so in the first method, second method, third method, and fourth method, all these, we tried out reciprocal or not, x over y or y over x. Well, it depends for each case. But in this example, the simplest is that you take its reciprocal so that its denominator is the simplest. You take its reciprocal and you take x over y be equals to u. So in this example, this method is the simplest. But for different types of questions, of course, different types of method will be simplest. And other than using this homogeneous substitution, there are other types of methods, and we'll learn those in the future. But right now, this method is the best for this example. If, for example, the question you get, the denominator is already the simplest, then you don't need to take its reciprocal, or else you just give yourself more problems. Okay, so for this lesson, I hope you can understand this. So if you like our videos, don't forget to subscribe to our channel, and we'll see you in the next lesson. Thank you for your watching.